Hello fellow splicers. Ever wondered how real-time analytics work with Splice machine? Let's see how.
In this tutorial, we will build real-time analytics with Splice machine. First, let's look at some examples of real-time analytics. Consider Pinterest. You have pin engagement data coming in. It may be required to enrich the pin with geolocation and pin category, and in real time view the number of pins by each city. Next, let's consider Twitter. There are 500 million tweets created per day and tens of billions of views of these tweets. It is required to annotate each of these tweets with impression count, that is the count representing number of views of these tweets in real time. For our example, let us consider advertisement impression logs. An impression is an ad view, so impression log will contain information like geolocation, advertiser, cookie for user, website, bid, etc. And we want to see in real time the number of impressions or the average sales bid by publisher or geolocation. Now let's look at the components that are required to build this real-time analytics. First, we will need a producer or simulator of impression logs. Next, we need a reliable transporter of these impression logs. We will use Kafka for that. Then we need a consumer to read these impression logs and process them, for which we will use Spark streaming. The processed data should be saved to a database which can support quick execution of queries. So we will use Splice machine for that. Finally, we use Zeppelin to view the real-time data from Splice machine. Before we go into the implementation details, let's first look at the working. So first let's look at Zeppelin. So here you can see Zeppelin is trying to show the data for the past 2 minutes. And since we don't have any data being put on the queue or any data being processed, that is why you see that it shows no data available, and this is being refreshed every minute. So every minute this graph is refreshed, showing data for the last 2 minutes. Before I run the actual consumer, I would run the Kafka default consumer just to look at how the impression log looks. So I will go here and I'm running the default Kafka consumer, and then here I will run the Kafka producer, which is writing impression logs onto the Kafka queue. So here we come, this is how the time impression log looks. So you have timestamp, publisher, advertiser, website, geolocation, bid amount, and cookie for each impression. I'll go ahead and stop this now. Let me go here and check nothing is running before I start the actual consumer, which is going to read the impression log and process it. So first let me make sure that no, there is no running consumer. So now let me go back and then I'm starting the actual consumer here. So I'm starting actual consumer, which is going to be reading the Kafka queue every 2 seconds. And let me see if the consumer started up. So let's come here and make sure the consumer application has started. Give it a minute. Oh, there you go. So this is where. So this is the one which is the application, consumer application running here, Spark streaming. So let's make sure it is completely up. There you go. So we have, so the streaming, it's all started fine. The consumer is started fine, and then there are no events because we didn't start the producer. So you see that there are no events that are returned to this. So let's go here and start the producer. So we see some events being. So I'm going to put 50 impression logs per minute on the queue. So now let's go back to the UI again and refresh here. So now you can see that the impression logs are coming through. So there are 50 events per second being written onto the queue. So my consumer is reading those every 2 seconds and processing them. Now let's go back to Zeppelin and see how if Zeppelin is, you can see that Zeppelin has refreshed and it is showing you the real-time data showing the impression sum by publisher and geolocation, and this data gets refreshed every minute showing the data for the last 2 minutes, so in real time, and this is connecting to Splice data mesh. Okay, let's see if it refreshes in the next minute. So let's just give it 30 seconds more to see it refresh. Maybe it needs more than 30 seconds because it's there you go. It's refreshing now. So it refreshes and shows the latest data. All right, now let's go back to the implementation details. So first we have the stream generator or the producer. So basically this one is producing the impression logs. So we have the list of geolocations to use here. So basically, if you come down here for every second, all it is doing is go ahead, randomly generate the data for impression log. Basically, randomly generate the website name, cookie name, pick the state random, and then create the impression log. So when I say I need 50 records it writes 50 records and then waits for a minute, for a second, and then writes the next 50. So it's like write 50, wait a second, write the next batch of impression logs, and the size of the batch is input to this. So when I run the Kafka stream generator from the command line, I have specifying the batch size. Now let's go and look at the consumer. So consumer is as we said, is a Spark streaming application. So we have here the Spark context, and then we are creating, these are all initialization, and we are, this one takes in arguments of the topic group. Then we have number of threads, and also we have the number of seconds. This is basically the batch time. So you can tell it to read like every 2 seconds from the queue and process the records. So here it is creating the D stream, reading from that queue, and here is where you're specifying what you're reading from the queue. In this case it is the impression log, and you specify the encoder and decoder for the decoders for the key. And we know in the D stream you will have a tuple, so we need to extract. We are extracting just the impression logs from the D stream, the stream that is just read in. So once we have the impression log, we are trying to filter out all the impressions with unknown geocode. So let's look at this one. So on this Java D stream, we are calling this function, which basically, let's go and look at the function. Here you can see that all it is doing is get the geolocation. If it is equal to unknown, return false, basically filtering out all the impression logs with unknown geolocation. Once we do that, next are going to map the impression log in the format of publisher in the pair, RDD pairs of publisher geo key object and aggregator log object. Basically, the reason we are doing this is we are trying to aggregate data, grouping by the publisher and geo code, and we are trying to aggregate timestamp, bid, and unique user. Basically, the cookie represents a user, so we are going to use that to identify the number of unique users, etc. So so that is why we are going to take the impression log and then map into this pair of objects where publisher geo represents the key, and then the aggregation log object actually contains the values for that needs to be aggregated. So we are creating Java pair D stream of publisher geo key and aggregation logs. So this is the function we are calling there to do that. So let's look at that aggregation function. So basically, aggregation function gets in an impression. The input to it is impression log, and it needs to output a tuple of publisher geo key object and aggregation log object, and how it is building that. So if you see the publisher geo key object, it's just taking the publisher and geo code and combining it. And in case of aggregation log, You're just taking the timestamp, the bid, and one is to represent the count of impressions. And here is the interesting one. The cookie is being converted into hyperlog log value. So these are the objects that are that impression log is being mapped to. And this is basically to assist with aggregation later on. So once we map impression log, the next step is to reduce by key and window. So basically what is happening is we are saying aggregate the values by key, where the key is publisher and geo. And when we say window, we are saying, how much of data we are taking to aggregate, because the data is coming in data is being put on the queue every second, and the consumer is reading every 2 seconds. So it's a continuous stream. So we want to kind of specify the window for which we are going to do aggregation. In this case, what we are doing is we are doubling. So basically, if you're reading the queue every 2 seconds, then for every 4 seconds, we are going to calculate the aggregates. And so that is what is happening here. Once the aggregations are done, then we call for each of the RDD that we are calling the save log RDD. So now let's look at save log RDD. Basically, it's doing mapping basically. So we have this publisher key aggregation log objects in the RDD. So we are converting that into aggregation results RDD. Basically, aggregation result record contains the publisher key, the geocode, then sum of the impressions, count of unique IDs, then the minimum timestamp and average sale bid. So this is how it is getting mapped. So the summing or aggregation is done when we call the reduce by key and window. And here we are just converting it to the proper object so that we can save it. So once the objects are mapped, we call for each partition, we call save log partition. So when we look at save log partition, this one is calling the insert statement, connecting to the Splice database and calling the insert statements, and it is using VTI to convert the aggregation result object into insert values. So this is where the actual save to the database is happening. So log aggregator is your main program, and then all these other functions are the supporting ones which get invoked to process the data that is being read from the queue. And we did look at objects here, like impression log object, aggregation log object, publisher geo key object. These are nothing but data objects, or POJOs basically. So here is the definition of each of those. So basically, aggregation log has fields, timestamp, and some bids, impressions, and unique HLL, that is hyperlog log. And aggregation result will have the timestamp, publisher, geo, impressions, uniques, and average bids. So this once the data is saved to the database, then in Zeppelin, you can plot using the aggregation result data in the required format. So in our case, we have a select statement, which is picking up all the rows, all the columns basically from the aggregation results table. That is where the aggregation results are saved into the database. And we are picking up the data only for the last 2 minutes, and it refreshes every minute. So here the graph is looking at the publisher and geo, and with values are sum of all the impressions, basically showing you the count of impressions by publisher and geocode. Thank you very much.